This is CPM Precalculus Chapter 2, number 164. So here we're given k of x. It's a piecewise defined function, 2x squared minus 4 for x is less than 2, 3x plus 10 for x is greater than or equal to 2. Alright, so part A is k of x continuous at x is equal to 2? Well, how do we figure this out? Remember what continuous means. Continuous means that you can draw the graph, basically, right? This is our understanding right now, without lifting your pencil, right? At x equals 2, especially here, like we don't care about x equals 25, but at x equals to 2, right? If here's our x-axis, our y-axis, 1, 2, 3, 4. At x is equal to 2, as long as whatever we're doing on the left, we get to 2, right? And we don't need to lift up our pencil and then starting to draw up here, for example. So if we get somewhere from the left to here, and then start here again and draw, there we do not need to lift our pencil. So what this is saying is both these functions, there's a transition at x equals to 2. So if we plug in x equals to 2 and figure out what the y value is for when it's less than 2, and we plug in what it is when x is greater than or equal to 2, when x is equal to 2, if those give us the same point, right? If they give us the same point, then we're going to be able to say, yes, it's continuous, and we don't need to lift our pencil. If they give us a different point, right? If they give us a different point here, then we're going to have to say, no, it's not continuous because we have to lift our pencil and finish drawing the graph, okay? So let's go ahead and try this out. The explanation is going to be our work, right? If continuous, then at x equals to 2, same point from both pieces. Let's go ahead and try this out. At symbol x is equal to 2, 2x squared minus 4. So here's the first piece. If we plug in x is equal to 2, this is equal to 2 times 2 squared minus 4. 2 squared is 4, 4 times 2 is 8, is 4. Okay, so if this is the same at x is equal to 2, then it is continuous. So let's go at x is equal to 2, negative 3 times x plus 10 equals negative 3 times 2 plus 10. Negative 3 times 2 is negative 6 plus 10 is equal to 4. Right? So they are equal. So therefore, the graph k of x is continuous at x is equal to 2, right? Because we get 4 outputted from both of them, 1, 2, 3, 4, right? No matter what happens to the left, it's a parabola, right? We already know what it kind of does look like, but let's just say we don't. Whatever happens to the left here, it's going to stop at this point, right? But and it's going to be an open circle. Let me go ahead and draw that. Whatever it is going to stop at this point, open circle. Then over here, it's going to start up again, close that circle, and go to the right. Okay, so that makes it overall continuous because if you take a pencil and draw the whole graph, you don't need to lift your pencil at all at x equals to 2. So the graph is continuous, and the explanation is here because the same point for both pieces is output. Okay, let's go into part B. Part B says if j of x is equal to k of x plus 1, what is the function for j of x? So j of x we know is equal to k of x plus 1, and we know then this is a piecewise defined function. So let's go ahead and plug in for every x, let's change it to be x plus 1 is our new input, right? The argument is x plus 1, so instead of x now we have x plus 1. So we have 2 times x plus 1 squared minus 4. 4, and here we have x, so we have to change that. X plus 1 is less than 2. And here now we have negative 3 times, instead of x, we have x plus 1 plus 10. 4, again, instead of x, we have x plus 1 is greater than or equal to 2. So now all we need to do is, we can just simplify this interval here. Subtract 1 from both sides, and we get x is less than 1. Subtract 1 from both sides, and we get x is greater than or equal to 1. So then let's rewrite j of x. And I like them in this form because this tells me that the parent function, right, quickly I can see is x squared, shifted to the left 1 unit, vertical stretch 2 units, shifted down 4 units, right? This one is a line shifted left 1 unit, vertical stretch negative 3 units, so that's vertical stretch of 3, reflection across the x-axis, shifted up 10 units. So keeping it in this format is good for us because we can quickly see what the graph is going to look like. So let's do that. Let's not factor this, let's not simplify this. Okay. And now we have for x is less than 1, right? And for x is greater than or equal to 1. So that's j of x. If you wanted to, you could simplify these, but I'm saying now let's not have to, but we know how to if we needed to. And that's the definition for j of x. And this ends CPM Precalculus Chapter 2, number 164.